lecture, we have started the nodal analysis. So aim of the nodal analysis is to find out the node voltages. So how to find out? So by applying the KCL, Kirchhoff's current law at that node. So we can get the equations of KCL. And so by solving that equation, we can find out the node voltage. And we have calculated one example based on this nodal analysis. So last time we calculated this and we got the answer. VA and VB, 5 and 2 volt, and we require to find out the voltage across 5 ohm resistance. So 5 ohm is connected between VA and VB node. So we subtract VA minus VB. So we get the voltage across the 5 ohm resistance. All of you get this answer? But then we get the answer. Anna? Is there any doubt in this example? Okay. Okay. And this example, same this example, same type of example I give you for homework. Here I give you the answer of this VA VB. So you get the voltage across 5 ohm is 1.82. This is for your homework. Okay. So I move for the next example. Write down. Use the nodal analysis to find the current in various resistors of the circuit shown in this figure. So first of all, draw this figure. And first identify the number of nodes in this circuit. Identify the reference node also. And then after give the direction of the current.
Sir, there are 2 nodes available in the below side. So which one are we supposed to take as the reference node?
See here there is no element is connected in any branch. Okay. So you consider that one as a common node. Clear? I show you the figure. You can see that you can draw this figure like this way also. Clear? And say that this is the reference node. This fourth node is a reference node. Clear? So your main node is 3. This is the first node. This is the second node. And this one is the third node. And this one is considered as a reference node because here there is no any element is connected between 2 nodes. So you consider as a common node. And we consider that is a fourth node as a reference node. Clear all of you? All of you clear? Yes or no?
Yes, sir.
Yes, sir.
Okay, so redraw this circuit like this way and give the direction of the current. So here, right hand side or left hand side, we have 10 amperes current source. So we consider that as a total current I. And at this node, it is divided into 3 branches. So we give the name of the current I1, I2, and I3. And this I2 current is again divided here in this node into 2 branches. So we call it as a I4 and I5. And same way here the current branch at this called as a I6. And here these are another current source of 2 ampere. Clear? So first of all, identify the number of nodes, reference node, and then after give the direction of the current in each branch. Here question is what? Use the nodal analysis to find the current in various resistors. So here you can see that how many resistors we have? Total 6 resistors. 2 ohm, 5 ohm, 4 ohm, 3 ohm, 1 ohm, and 5 ohm. So you need to find out all the 6 current I1, I2, I3, I4, and I5 and I6 by using this nodal analysis. So here you have 3 nodes, 1, 2, and 3. So apply the nodal analysis, apply the KCL at all these 3 nodes, make the equation, make the matrix form by the Cramer's rule, solve this equation and find out the VA, VB, and VC. Okay? At node 1, we call the voltage VA. At node 2, we call the voltage VB. At node 3, we call the voltage V3. Clear? So you can see here, we apply the KCL at node 1. All of you first understand this, then after write this. So at node 1, incoming current is what? This total current I. And what is the outgoing current? I1, I2, and I3. So here I write the apply KCL and write I1 plus I2 plus I3. This is the outgoing current is equal to incoming current I. Clear? So what is I1? Current flowing into this branch. that is nothing but voltage at node 1, we call as a V1 divided by 2 ohm. Okay, or you can say that voltage V1 minus voltage at node V4, but we always take the reference node voltage is zero potential. So it is V1 minus 0 divided by 2. So you can see here I1 is what? V1 divided by 2. Same way I2 is what? Current flowing into 3 ohm resistance. That is what? Voltage difference between V1 minus V2 divided by 3 ohm resistance. So that's why he have written V1 minus V2 divided by 3. Then I3 is what? Current flowing into 5 ohm resistance. That is a resistance between node 1 and 3. So it is a voltage difference V1 minus V3 divided by 5 ohm. So it is V1 minus V3 divided by 5. And I is the total current, which is a current source of 10 ampere. So equal to 10. So if you solve this equation, if you simplify this equation, so you get this equation 31 V1 minus 10 V2 minus 6 V3 is equal to 300.
Sir,
All of you understand this?
sir, can you repeat one?
Yes, sir.
Okay, again repeat. Here we apply the KCL at node 1. First of all, you identify the number of main nodes. So we have 3 nodes, 1, 2 and 3, and fourth one is a reference node. So we not apply the KCL at reference node, we apply the KCL only for this 3 node, 1, 2 and 3. Yeah? So node 1, apply the KCL. So as per the KCL law, states that incoming current is equal to outgoing current. So incoming current is what? At node 1, only I, total current. So I is equal to outgoing current. Outgoing current is I1, I2 and I3. All these 3 current are leaving from the node 1. So all are the outgoing current. So I is equal to I1, I2 plus I3 as per the KCL. All of you understand this part up to this? Then,
Yes,
then what is I1? Current I1 value is what in terms of voltage? So at node 1, we call the voltage is V1. Here. So voltage V1 divided by this resistance of this branch, that is nothing but current I1, because current I1 is flowing into this 2 ohm resistor. So how much current is flowing? So that is equal to voltage at node 1 divided by that branch resistance. Okay. So that's why we write V1 divided by 2. Then I2. I2 is what? Current flowing into this 3 ohm resistor. So in terms of voltage, how can we write? So node 1 voltage is V1, node 2 voltage is V2. So V1 minus V2 voltage divided by this 3 ohm. So we get the current into this 3 ohm resistor. We replace I2 by V1 minus V2 divided by 3. Same way, this I3. So I3 is what? Current flowing into this 5 ohm resistor, which is connected between node 1 and node 3. So voltage difference between these two nodes, which is V1 minus V3 divided by this branch resistance, which is 5 ohm. So that gives the current I3. So replace the I3 by V1 minus V3 divided by 5. And equal to total current is your 10 ampere current source is equal to 10. So if you simplify this equation, you get this equation 31 V1 minus 10 V2 minus 6 V3 is equal to 300. Clear all of you now? All of you clear?
Yes, sir.
Yes,
sir.
Yes, sir.
Okay. So same way, apply the apply the KCL at node 2 and 3 and write the equation. All of you write KCL at node 2 first, then after KCL at node 3. All of you write written. So first of all, identify the incoming current at node 2. What are the incoming current at node 2? I2. Here, I2 is towards the node 2. And what are the outgoing currents?
I4
and
I5.
I4 and I5. So as per the KCL equation is what? I2 is equal to I4 plus I5. Here. Now what is I2? I2 current is what in terms of voltage? V1 minus V2 divided by 3. So V1 minus V2 divided by 3 is equal to I4. I4 is what? V2 minus V3 divided by 1. And I5 is what? V2 divided by 5. Because at node 4 potential is 0. So V2 divided by 5. Clear? So you get this equation. 5V1 minus 23V2 plus 15V3 is equal to 0. આવે છે બધા?
Yes, sir.
Okay.
Yes, sir.
Same way, apply the KCL at node 3. Those who get this equation, equation number 2. Then next, apply the KCL at node 3. So at node 3, what is the incoming current? What are the incoming currents? I4 and I3.
I4 and I3.
So I3 plus I4 is equal to what? Outgoing current. Outgoing current is how much? I6
And
plus
I.
this 2 ampere. Plus this 2 ampere. Clear? This 2 ampere is also a direction is from leaving from the node 3. Clear? So equation is I3 plus I4 is equal to I6 plus this 2 ampere. Clear? Now write down this current in terms of voltage and resistance. So I3 is what? V1 minus V3 divided by 5. I4 is what? V2 minus V3 divided by 1 is equal to I6 is what? V3 divided by 4 and plus 2 ampere. So as you apply KCL at node 3, you get this equation. 4V1 plus 20V2 minus 29V3 is equal to 14. There, this equation number 3. All of you take your time and get this equation, all equation 1, 2, and 3.
Sir, all of these examples are in the PDF that you provided yesterday in the book.
Yes, maybe some of are available, maybe some of are not available. Okay.
Okay, sir.
This example is available in your VK Mehta. જે કાલે તમને બુક આપી એમાં એક્ઝામ્પલ અવેલેબલ છે. Okay, all of you get this equation 1, 2, and 3.
Yes, sir.
Now write down this equation in terms of matrix form, and by using the Cramer's rule, solve this equation and find out V1, V2, and V3. Same as we have done in the last example. Find out V1, V2, V3 by using the Cramer's rule. First, write down these 3 equations in matrix form. So here I directly give you the answer. You calculate later on this value. So here I get the answer V1 by using the Cramer's rule. This value V2 and this is a V3. Clear? So I get this V1, V2, V3 by using the Cramer's rule. Now our aim is what? To find out the current flowing into the each resistance. So we have total 6 resistance. So we need to find out the current into all these resistors. So first we need to find out I1. So I1 is what? That is a current flowing into this 2 ohm resistor which is connected between node 1 and 4. At node 4 potential is 0. At node 1 voltage is V1. So the current flowing into this 2 ohm resistance branch is equal to what? V1 divided by 2. Clear? So current flowing into this branch 2 ohm resistance I1 is equal to what? V1 divided by 2. So V1 is this value and divide by this 2. So you get answer 6.03 ampere. Okay. Same way, current flowing into this 3 ohm resistance which is I2. You can see that current flowing divided by 3. Already to put this value V1 and V2 and divide with the 3. So you get the answer 2.32 ampere. Same way you can find out the current in the 5 ohm resistance, which is I3. V1 minus V3 divided by 5. So you get the answer 1.65 ampere. Same way in the remaining resistance. Or if you directly write this V1, V2, V3, you calculate later on by using the Cramer's rule.
Sir, I had a doubt, sir.
Yes, please.
Sir, I had a doubt in I3 and I4. How we are calculating in terms of voltage and resistance? I had doubt. How is I4 V2 minus V3? Through the diagram, I wanted to understand.
See, this is the diagram. V2 is the voltage at node 2, V3 is the voltage at node 3. Clear? So what is the potential difference between node 2 and 3? That gives the voltage across the 1 ohm resistance. So
Yes.
current flowing into the 1 ohm resistance is what? Voltage across this 1 ohm divided by its resistance. Clear?
Yes.
How much voltage across 1 ohm? V2 minus V3. That we already calculated. And
Yes.
divide by its resistance 1 ohm. So we get the current flowing into this 1 ohm resistance, which is I4. Clear?
Yes, sir.
Same way for this 3 ohm resistance. Current flowing is I2. So current I is what? V divided by R. So voltage across 3 ohm divided by its resistance, that gives the current I2. So how much voltage across 3 ohm? V1 minus V2
Yes.
and divide by 3. Clear? All of you?
Yes, sir. And I6, sir.
I6 is what? That is a current flowing from node 3 to 4. So what
Yes.
is the potential at node 3? V3.
V3.
And what is the potential at node 4? We consider as a reference node. So potential is what? 0.
0.
So we write equation is what? I6 is equal to voltage V3 minus 0 divided by its resistance 4. Or you can write directly V3 divided by 4. Clear?
Yes, sir. Clear.
Is there any other doubt? Anyone? So you get the answer I1, I2, I3, this one. Same way, I4, I5 and I6, this one. I4 is what? V2 minus V3 divided by 1. I5 is this one, V2 divided by this. V2 divided by 5. This one. And I6 is V3 voltage divided by 4. This one. All of you get this answer?
Yes, sir.
Sir, I1 will be.
Yes, sir.
Yes.
Sir, I1 will be V1 divided by 2.
See, current I1 is what? Which is flowing between node 1 and 4. So it is V1 divided by 2. Simple. Because node 4 voltage is 0.
Yes, sir.
Clear? So it is
Yes.
V1 divided by 2. See this one. V1 divided by 2. See, same thing we have written in the KCL also. You can see the equation number 1, KCL. Here we replace I1 by what? V1 by 2. Clear? Same way, I2 is what? V1 minus V2 divided by 3. Clear? So we already calculated, we already write this equation of I1, I2 and I in the KCL. Okay. All of you clear this example? Is there any doubt?
No, sir.
No, sir. Clear, sir.
Okay,
No,
so
sir.
let's move for the next example.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Write down next example. Find the current in the various branches of the circuit by using nodal analysis. So here this is the circuit diagram. So here already number of node is given A, B, C. Clear? That is your main, A, B, C and D. 4 nodes. And here this is a common node. So this is taken as a reference node, E and F. There is no element connected between these 2 nodes. So we consider as a common node and consider as a reference node. So total 4 main nodes. So we apply the KCL at all these 4 nodes, make the equation, solve this equation, and find out the voltages. And then after we find out the current in the various branches.
Sir, so the nodes which do not have a resistances near them are said to be reference nodes, are made reference nodes.
What is the question? I don't understand.
Sir, how do we find out reference? Which are the reference nodes? That is my question.
See, generally this there is no rules to how to select the node or reference node. But generally this lower sides nodes are considered as a reference. Clear? This one. See, in all the circuit diagram, we consider this lower side node as a reference node. Here there is no element is connected between any node, any 2 points. So we consider as a common node this one. Clear? You can
Yes.
redraw the circuit same like our previous example and consider this 2 node as a 1 node. Clear?
Yes, sir.
So
Sir,
here
then
in
what,
yes,
sir, what will the potential be at E?
what?
The potential at B and E both is VB.
Zero.
Sorry, what is your question?
It will be
Or the
VB by
potential at
equal to
point B and E both will be VB.
No. That is the potential difference between B and E. So
Oh,
what is the potential at node E? Because we take as a reference, so potential is 0.
Zero.
And point B, voltage is VB. So voltage difference across B and E point is what? VB minus 0. So that's why it is say that is VB. Clear?
Okay.
See that. That is the potential across between B and E point. Same way here, potential across C and F point is what? VC. But it is actually is what? VC minus 0. Because E and F both are the reference node. Because that is a common node. There is no element here. Here. So potential at point C is VC. Potential at F is 0. So it is VC minus 0. So we consider as a VC. Clear? All of it clear?
Yes, sir. Yes,
Now,
sir.
in this example, you not need to apply the KCL at all the nodes. Why? The reason is that at node A, you already know the potential because here voltage source is given. Clear? In the previous example, current source is given. In this example, both the side current source is given. So we not know the potential at node 1 and node 3. But in this example, voltage source is given at both the side. You can see here. So at node A, already you know the voltage VA. It is how much? 100 watt. Clear? Same way at node D, the voltage is given 80 watt. So here at node A and D, you not need to apply the KCL because you already know the voltage at node A and D. So you only apply the KCL at node B and node C. Clear? All of you clear? Because at only node B and C, the
Yes,
voltage
sir.
is unknown. At
Yes, sir.
node A and D, voltage is already given because your voltage source is provided. Clear? So you apply the KCL at node B first, then apply KCL node C, solve both this equation and find out VB and VC. And here our aim is same as find out the current in various branches. So here current is given I1, I2, I3, I4 and I5. So you know all the voltages at all the nodes. So you can easily find out all these 5 current. Clear? So I give you a hint. So you calculate by yourself now. Your time start now.
Sir, we can get directly the value of I1. no?
What?
We can get the value of I1 directly. No? 100
How to
divided by
calculate
20.
I1 directly?
100 divided by 20. There is only one resistor in the first node. So I1 is
But-
passing through it.
No. I1 minus VB divided by 20. And VB is the unknown quantity. So how to find out VB? So first apply the nodal analysis. Clear? So that's why first apply the nodal analysis and find out this voltage VB and VC. Then after you can calculate all the branch current. I1, I2, I3, I4 and I5. Clear?
Yes, sir.
Same way you can see here this current I5. So I5 is what? Voltage difference between node C and D. So it is VC minus VD divided by 10. Here VC is unknown quantity. VD is given 80 volt. Clear?
Sir,
Yes.
sir, I got equation number 1.
Okay. So this is the equation number 1. 30 VB minus 4 VC is equal to 300 at node B.
Yes, sir.
Incoming
Yes,
current
sir.
is I1, outgoing current is I3 and I2. Clear? So I2 is what? It is VB divided by 10 ohm. You can write VB minus 0 divided by 10, whatever you want. Then I3 is what? Current flowing between node B to C. So it is VB minus VC divided by 50. Clear? So when you apply the KCL, you first write down the voltage from the node where the current is leaving. So here current I3 is flowing from node B to C. So first take the voltage VB and subtract VC from this VB. So VB minus VC divided by 15. Same
Sir.
way equal to I1. Yes.
So can I assume all the current moving outwards? So my formula will be a little different from yours.
But suppose in an exam, this direction is already given, then you cannot consider your direction. Clear?
Oh, okay, sir.
Suppose the direction is not given in the example, then you can consider any direction. Clear? But in
Yes,
this
sir.
example, direction is already given. So write down the equation based on the direction of current.
Okay, sir.
Is 30 VB minus 300. બધાને આવે છે? Yes.
Yes, sir.
Do we have to consider E and F as a single node?
What? Sorry.
Do we have to consider E and F as a single node, right?
Yes. You can consider E and F as a single node, reference node. Or you can
They
draw
both
this.
They both are connected through different potentials. So how can they be considered as a single node?
Where it is connected different potential. Both are at the same point because there is no element connected here. There is suppose any one resistance connected here between E and F, then we can say that both are at the different potential. Clear? Here, suppose E at point E we consider 0 volt. So same 0 volt you can get at the point F because there is no element between E and F. Clear? જો કોઈ એલિમેન્ટ જ નથી તો પોટેન્શિયલ સેમ જ હશે. Clear?
Okay.
All of you clear? So same way here you can see that between B and C point. So suppose here this 15 ohm resistance is not present here, then the voltage at B and voltage at C that remains same because there is no any element between B and C. That here 15 ohm present, that's why potential at B and C is different. Clear? But here there is no element, so we consider as the same potential. So if E considered as a zero potential, so F is already automatically becomes zero potential. Clear? All of you clear?
Yes, sir.
Okay, same way apply the KCL at node C. So incoming current at node C is 3 and outgoing current is I4 and I5. So apply the KCL. So I4 plus I5 outgoing current is equal to incoming current I3. So I4 is what? Current flowing into 10 ohm. That is the voltage difference between C and F. That is nothing but VC. That is VC divided by resistance 10 ohm. VC divided by 10. Replace this I4 and I5 is VC minus VD divided by 10. But here you can see that at D terminal voltage is what? Minus 80 watt. So when we write VC minus VD, so minus minus plus, so that's why it becomes VC plus 80. At D potential, at D point voltage is what? Minus 80 watt. And our equation is what? VC minus VD. So that's why this minus minus plus. So the I5 becomes VC plus 80 plus 10. Sorry, divide by 10. Equal to I3. I3 is what? Current flowing into this 15 ohm from B to C, VB minus VC divided by 50. So if you simplify this, so you get VB minus 4VC is equal to 120. So this is your equation number 2. All of you get this?
Yes, sir.
Sir, again, so this one again.
Yes, sir.
1 second.
So solve this equation and find out the value of VB and VC.
Excuse me, sir.
Yes?
Sir, can you explain that VC plus 80, how it is there?
VC plus 80. Okay. What is I5? We replace this value by I5. Okay. I5 is what? Current flowing into 10 ohm resistance. So current flowing into 10 ohm resistance is what? Voltage across this 10 ohm divided by its resistance. So it is VC minus VD divided by 10. Yes or no?
Yes.
Okay. But here
Yes, sir.
at node D, what is the voltage? Minus 80, because negative terminal of this voltage source is connected with point D. Here. So potential at node D,
Yes,
it is
sir.
minus 80. Here. So it is minus minus plus. That's why here it is VC plus 80. Same way you can see here at node A, the positive terminal of the voltage source is connected. So that's why we take as a positive 100. So I1 is what? Plus 100 minus VB divided by this 20. So you always keep in mind what is the polarity of the voltage connected at particular node, positive or negative. If positive is connected, then we consider as a positive voltage. If negative polarity of voltage is connected at node, consider as a negative voltage at that node. Clear?
Yes, sir.
So what is the value of VB, VC? So here you can also
VB is
solve this equation without any Cramer's rule, because there is two equation only.
VB.
Yes?
VB is equal to 15.
VB 15.
Yes. So here VB is 15 volt and VC is minus 26.25.
Sir, in exam, if we use simultaneous equation, is it okay?
Yes, yes. So here another way, this equation also solved by using the Cramer's rule also. Or you can subtract equation number 2 from the 1. So you get this equation 12 VB is equal to 180. So you get the VB is equal to 15 watt and put this value VB in equation number 1. So you get the VC is equal to minus 26.25 watt.
Sir, when we have just defined two potential differences, and if we don't use Cramer's rule, we will still get marks.
Yes, yes, you can get marks. If you are able to directly solve, then there is no need to apply the Cramer's rule. Okay.
Okay.
But for the complicated circuit, there are more than 5, 3, 4, or 6 equations. At that time, this Cramer's rule becomes easy for you to find out the answer. Here only 2 equations, so there is, I think, no need to apply the Cramer's rule because easily you can get the answer, VB and VC. So whatever method you like, you can apply and get the answer. Okay?
Yes, sir.
Yes, anyone doubt?
Sir, in place of that 100 volt, the minus sign, negative sign would be in the top. Then it would be minus 120, no?
Why 120?
Minus 100, minus 20.
Which 20? This is a 20 ohm resistance, not a voltage.
Okay, sorry, yeah.
This is a voltage source, this is a resistance. Okay? You cannot add voltage and resistance.
Sorry, yes.
Okay, all of you get this VB and VC. So our aim is what here? To find out the current in all the branches. So all the branches we have written already current I1, I2, I3, I4 and I5. So find out all this current. So what is I1? Current I1 is what? VA minus VB divided by 20. Clear? So what is your value of I1? All of you find out I1. I1 is potential difference between A and B divided by resistance. VA minus VB divided by 20. So VA is already known. 100. Yes?
4.25
ampere.
Yes. And same way current I2 is what? Current I2 is flowing to 10 ohm. So it is VB divided by 10. Yes. It is 1.5. Same way I3 is what? VB minus VC divided by 15. So you get the answer 2.75 ampere. Same way find out I4 and I5. So you get this answer. So here you can see that the answer of I4 is negative, minus 2.625. So it means that the direction given in the example, that is wrong. The current I4 is flowing exactly opposite to the direction given in the example. Here. So I4 you can see that current is flowing from C to F, but actually it is flowing from F to C. Yes?
Sir, what is the meaning of negative potential? In VC, we got negative potential. That's why.
VC, you get the negative potential.
Yes, sir.
Clear. So here we apply the KCL at node C and assume that potential at node C is positive. Clear.
Okay.
With respect, due to this regarding, we apply the KCL at node C. But value of VC is negative. It means what? The potential at node C is negative as compared to point F. It means positive polarity at F and negative polarity at point C. Clear? So this VC voltage across node C and F with polarity at C node negative and at node F positive. Clear? Same way. Yes.
We consider potential at F equals to 0.
Yes.
That's why.
So what? VC is the potential difference across this branch. VC is not a voltage at F.
Okay.
Remember, potential at any node and potential across any branch. Both are the different things.
Okay.
Clear? Here at this branch, at node D, why you take the voltage minus 80? Because here voltage source is already given.
Yes.
But here between node C and F, there is a resistance.
Okay.
So you need to find out voltage difference between two nodes. VC minus VM. Then you get the voltage across this.
Okay.
So all of you get this answer? I1, I2, I3, I4 and I5?
Yes, sir.
Okay. Very good. So next example I give you for the homework. Same type of example. First of all, write down this example. Find the power consumed in the given circuit. This is your circuit diagram. Current direction is already given. So first of all, I give you the idea how to solve this example. This is for your homework. So same way as the previous example, we calculate this. So first identify the node. So here node is already given A, B, C, and E. That is your main node, and reference node is D. Now our aim is what? To find out the total power consumed in the circuit. So here we have number of resistors 1, 2, 3, 4, and 5. So whatever the power loss in this resistance, if we sum all this power loss, then that gives a total power consumed in the circuit. Here. So for that, we need to find out all the branch current. This I1, I2, I3, I4, and I5. Then we can find out the power loss. As per the equation of power is what? I square R. I think all of you familiar about the equation of power loss. P is equal to I square into R. So suppose you find out the power loss in this 1 ohm resistance. So you must know the value of I1. So I1 square into R, this 1 ohm resistance, that gives a power loss in 1 ohm resistance. Clear? Same way you can find out this power loss in 0.5 ohm. For that you need to find out first I3. Same way find out the current I2, I4, and I5. So then you can find out the total power loss. So after find out the current I1, I2, I3, and I5, find out the power loss in each resistance, and then sum all this power loss. So that gives a total power loss. So how to find out this current? So for that, you first find out the voltages at all the nodes. Clear? Then you can find out this current. So at node A, what is the potential?
15.
So V1 minus.
Okay, so at node A, you not need to apply this KCL. So node A, we already know the voltage. Now node E, what is the potential?
20.
20. So same as the previous example, you need to apply the KCL only at node B and C, because at node B and C, the potential is unknown. Here, and at the reference node D, potential is 0. So same as the previous example, apply the KCL at node B and C. Solve the equation, find out VB and VC. Then after find out all this branch current I1, I2, I3, I4, and I5. And then after find out the power loss in each resistance. Equation is I square R. Suppose you find out resistance is 1 ohm. So it is I1 square into R. Suppose you find out the power loss in 0.5 ohm. So it is I3 square into 0.5. Same way in 2 ohm. So it is I4 square into 2. And then after sum all this power loss, so that gives the total power loss. So just I give you the overview. You can see that apply the node B. I get this equation 4VB minus 2VC is equal to 15. Then at node C, I get the equation 4VB minus 7VC is equal to minus 40. Solve both this equation and you get this answer. VC is equal to 11 volt and VB is equal to 9.25. Then after find out current I1, I2, I3, I4, I5, and then after find out the power loss. I1 square into 1 ohm plus I2 square into 1 ohm, I3 square into 0.5 ohm, I4 square into 2 ohm plus I5 square into 1 ohm. So that gives the total power loss and you get the answer 266.25. So that is for your homework. I already give you the overview. All of you do this example by yourself without seeing in this presentation. Okay, all of you clear this nodal analysis. When I get doubts in nodal analysis or mesh analysis, so here I complete this topic, nodal and mesh analysis.
Sir, in exam, we can do any method which we want from
Yes,
both.
yes, whatever you like, you can use any method. But this Cramer's rule is a very simple method. Suppose if you have large number of mesh is given in the mesh analysis, so this Cramer's rule becomes very useful and is easy method to find out the answer. Yeah, it is a very lengthy method, but it gives a correct answer. Yeah, as compared to other methods. And it is not complicated method, it is an easy method. So whenever circuit is complex, suppose in mesh analysis, 3 or 4 mesh is given, 5, 6 mesh is given, then you can use this Cramer's rule. Same way in the nodal analysis, 5, 6 nodes are given. So equation becomes 5 or 6. So at that time, you can apply this Cramer's rule. Otherwise, you can solve by any method. Clear? All of you?
Sir.
Yes.
So will simple calculators be allowed in the exam?
Yeah, simple calculator is allowed.
Okay, sir.
Okay. So our next topic is series parallel circuit. So you already know what is the series connection of resistance. So what is your equivalent resistance? Same way for the parallel connection of the resistance, what is its equivalent resistance? So I just summarized this part because you already learned this part in your physics 12th or 11th standard. So suppose here R1, R2 and R3 that is connected in series. So for series connection, the total resistance is nothing but a summation of all these three resistance, R1 plus R2 plus R3. Clear? Same way, suppose the resistance are connected in parallel, R1, R2 and R3 connected in parallel. So its equivalent resistance you can write down by using this equation. It is 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Whatever number of resistors are connected in parallel. So R equivalent you find out by this way in parallel connection and in series connection by using this equation. And as you know that in the series connection, when all the resistors are connected in series, current flowing in all the resistors are remain same. Where in the parallel connection, the voltage across all the parallel branch that is remains. So you can see here in this equation and series connection, R equivalent is what? V divided by I. So V is what? Voltage across R1, voltage across this R2 resistance, and voltage across R3 is V3. So it is V1 plus V2 plus V3 and divide by the current flowing into this all the resistance. So that is common I. Clear. But in the parallel connection, current is different because parallel connection current is divided. So here one current is flowing into R1 is different, R2 is different, R3 is different. So it is I1, I2 and I3. So total current I that is equal to what? I1 plus I2 plus I3. So you can write down by this way V1 divided by R1. You replace the I1 by V1 divided by R1. V1 is the voltage at this point. So V1 divided I2 is current flowing into this R2. So that is V2 at this point voltage is V2 divided by R2. So that gives the current I2. Same way I3 is V3 divided by R3. So in the parallel connection, voltage across each resistance is remains same. Where in the series connection, current flowing into each resistance that is remains same. I think all of you know this. Clear? All of you clear this series parallel? It is very simple. So here I show you in table form what is the equation when you connect capacitor in series parallel, resistance in series parallel, and inductor in series parallel. So series connection of capacitor. Suppose two capacitors are connected in series, C1 and C2. So its equivalent capacitance you can write down by this equation. 1 upon C. C is your equivalent capacitor. So 1 upon C is equal to 1 upon C1 plus 1 upon C2. So this C equivalent you get by this equation. Suppose resistance is connected in series R1 and R2. So simple addition of these two resistors, so that gives a total equivalent resistance. Same way, suppose two inductors are connected in series L1 and L2. So summation of these two inductors that gives a total inductance of the circuit in series connection. Now in parallel connection, suppose C1 and C2 are connected in parallel. So at that time you make the addition directly, same like a resistance connected in series. So in parallel connection of capacitor, the equivalent capacitance you can find out by directly adding the value of two capacitors, C1 and C2. Then resistance connected in parallel, R1 and R2 is connected in parallel. Then its equivalent resistance you calculate by this equation. As we see in the previous slide, 1 upon R is equal to 1 upon R1 plus 1 upon R2. and inductance are connected in parallel, L1 and L2. Then this equivalent inductance you can find out by this equation. 1 upon L equivalent is equal to 1 upon L1 plus 1 upon L2. So this is the series parallel connection of capacitor, resistance, and inductor. Now, what is the formula of voltage in case of cap? So how much voltage across capacitance? The voltage across capacitance is what? Equal to Q. Q is what? Charge. Charge on the plate of the capacitor divided by its capacitance value. So delta V or voltage across capacitance is equal to Q by C. Then what is the voltage across resistance? So equation is what? I into R. Current flowing into the resistance and into its resistance, that gives a voltage across that particular resistance. So delta V is equal to I into R. Same way, if you find out voltage across inductor, so that gives so that you can find out by using this equation is equal to minus L di by dt. L is the inductance of this inductor, and di by dt, that is nothing but rate of change of current flowing into this inductor. So that is a voltage equation for all these three parameters: capacitor, resistance, and inductor. And this is a series parallel connection of all these elements. All of you understand this one? Series parallel formula? Okay.
Yes, sir.
Yes, sir.
I think all of you know this. But I will be physics ma tamara.
हाँ सर.
Yes, sir.
Okay.
Yes.
So I'm directly move for the next example related to the series parallel connections. I think time is over. So here I stop this lecture. In next lecture, we will start the series parallel connection examples. So up to this lecture, up to this point, is there any doubt in this lecture?
No, sir.
Okay, so you can now leave this.